Good day, everyone. So for this today, we are going to talk about electric charge and electric field. So at the end of this lesson, we are expected to be able to describe the nature of electricity, compare the two ways of charging an object, solve forces acting on two charged objects using Coulomb's law, draw electric field lines of charged objects, and solve for the electric field due to point charges. So we recall that there are four fundamental forces in nature. First, we have the gravitational force, then we have the weak force, um, the nuclear force, or the strong force, and the electromagnetic force. So our focus is on this one, the electromagnetic force, which involves electromagnetism. So electromagnetism is the combination of electric and the magnetic phenomena. So it's a combination of the two. So this is the root of computers, television. We have computers, we have televisions, we have radio, we are able to communicate, telecommunications, household lighting, and even the ability of food wrap to cling to a container. So the physics of electromagnetism was first studied by the early Greek philosophers who discovered that when amber, which is a petrified tree resin, is rubbed with a piece of cloth, will attract small pieces of leaves or dust. So same concept like when you brush your hair and then murag mo um mo pasaka siya sa atong hair, no? Something like that. So they also discovered that if a certain type of stone, which is a naturally occurring magnet, is brought near bits of iron, the iron jumps to the stone. So kani siyang pag-discover nila sa amber upon rubbing to a piece of cloth niya mo attract of small pieces of leaves or dust. Mo ni siya ang split na ni siya ang electromagnetism into two. So kani siya nga portion, this is the foundation for electricity. And for this naturally occurring magnet, of course, for magnetism. So two different nga concepts. But later on, another branch of physics was discovered, which is relating these two na. So muna to siyang electromagnetism. So our focus is first here on this, electricity. So the word electricity comes from the Greek word electron, which means amber. So the amber effect is called static electricity. Unsa mang amber effect katong mag-rub ka og certain material to another material and then it will attract by the dust, by the small pieces of paper, which is probably performed in the experiments in high school, or small pieces of leaves. It's called static electricity because there is no motion of the charges involved. So as a result of the rubbing between objects, they become charged and they are said to possess a net electric charge. So again, static because these charges are not moving. So for example, we have two charged plastic rulers. So how do we charge these rulers? So just rubbing them on piece of cloth. So they are of the same material. So after rubbing them on another material, then kung i-bring sila close to each other, then they will repel. So if other type of material, for example, a glass rod, pwede niya i-rub siya sa cloth. Niya after that, they are brought close to each other, then they're expected also to repel. But then if this charged ruler and this glass rod are, brought close to each other, they're expected nga ma-attract sila. So by this, it has been concluded that like charges repel and unlike charges attract. So syempre, like yun ang kaning sa ruler kay same man sila og material. Same sa dong object nga kung asa sila girab. Also for the glass rod, but they are different nya ni attract sila. So like charges repel and unlike charges attract. So these two types of electric charges are suggested by Benjamin Franklin. So he said that there are two types of charges, and he classified it as the positive charge and the negative charge, which is very much related to the subatomic particles. So we recall that there are three subatomic particles: the electrons, the protons, and the neutrons. So the electrons are the negatively charged particles, and the protons are the positively charged particles, and the neutrons are those which have no charge. So the magnitude of the charge of the electrons and protons are equal. It's 1.6 times 10 to the negative 19 coulomb. However, their signs are opposite. So of course, electrons negative and the protons are positive. So just like matter and mass and energy and momentum, electrical charges are also conserved. So it is stated that the algebraic sum of all the electric charges in any closed system is constant. In any charging process, the charge is not created nor destroyed. It is merely transferred from one body to another. So just like in energy or matter, no? And the magnitude of charge of the electron or proton is a natural unit of charge. So based on the ability of the charge to move through materials, na-classify ang different types of materials as conductors, non-conductors or insulators, semiconductors, and superconductors. So conductors are those materials through which charge can move freely. So, ang pinaka-good nga conductors kay ang metals. So, non-conductors or insulators are those materials which charge cannot move freely, like for example, plastic or rubber. Semiconductors are materials that are intermediate between conductors and insulators. So examples of these are silicon and germanium and computer chips. And if you look at this in the periodic table, if you notice na diba, on the left side of the periodic table are the metals. So moto sila ang mga conductors. On the right side nila ang mga non-metals. So generally, non-metals mo na siya ang mga insulators or non-conductors. But in between them, na siya hagdan din ha. There is a kind of like steps na. So those elements nga ma-find na to nga murag stairs, those are semiconductors. So they have metallic and non-metallic properties. So two of these are silicon and germanium. And superconductors are materials that are perfect conductors, which allows charges to move without any hindrance. So one very good example of a superconductor is the metal aluminum. And there are other materials also that are superconductors. So for charging objects, there are two ways wherein we can charge an object, either by conduction or induction. So charging by conduction involves the contact of a charged object to a neutral object, so which is shown here. So say for example, we have a negatively charged rod and we have a sphere, no? We have this sphere which is neutral. So meaning equal ang, diba, in chemistry we learned nga for neutral objects, the positive and the negative charges are equal. So protons equals the number of electrons. And then ma-charge ang object, let's say for example, ganiha kadong rubbing. In charging, di ba, by rubbing, nganong ma-negatively charge man siya? Probably because kadong naatoy siya cloth dire, na cloth, niya upon rubbing with the cloth, nganong na-negative charge man siya? Because the electrons from the cloth kay ni transfer to the ruler. Munang na-negatively charged siya. So expect na positively charged ang cloth, nga naman nakuhaan naman siya og electrons. Diba? That's how ions are formed. So same concept. So here we have a sphere which is neutral, so equal ang positive and negative charges, and then we have the negatively charged rod. So before contact, the negative rod repels the sphere's electrons, inducing a local positive charge kay pundok man here ang mga positive charges. And then the rod is brought to contact with the sphere. So after the contact, the electrons from the rod flow into the sphere. So, maadto siya sa sphere, ang electrons, neutralizing the local positive charge. So, na-neutral na to here, kaya na-balance man ni sila. Pag-flow niya diha, na-neutral na here. And then when the rod is removed, the negative charge remains on the sphere. Kadong negative charge nga ni neutralize no sa kuan, sa local positive. So kadong negative charge here, excess na to. So therefore the sphere becomes negatively charged. Kaya na naman daan here ang mga negative. Okay, so that is charging by conduction. And then by induction. So in induction, if in conduction there is a contact, in induction there is none. So charging by induction involves holding a charged particle near an uncharged conductive material that is grounded on a neutrally charged material. The charge goes between two objects and the uncharged conductive material develops a charge with opposite polarity. So for us to understand, so here. So for example, we have here a neutral sphere. So neutral meaning equal number of positive and negative charges. And then, if it brought close, no, we have a negatively charged rod, and then it brings siya close to the sphere, electrons redistribute, no? Just like what happened earlier sa kadungkuan. But this time, wala lang gitouch. It's just brought near the sphere. And then, pag redistribute sa electrons, katong ni mo-repel, no? Magtapok here on the right side ang electrons, kay mo-repel man siya sa negatively charged na rod. After that, i-ground ang sphere. So some electrons will leave the grounded sphere through the ground wire. Others call this earth, i-earth siya. So, ato sa ground. So, the electrons, kay mo-repel man siya, so the electrons will leave, no, through the ground wire. So what happens after that? Pag leave niya through the ground wire, i-leave naman siya, excess positive charge is non-uniformly distributed na. And then the remaining electrons redistribute uniformly and there is a not uniform distribution of positive charge on the sphere. So dili tanan electrons na hurot og leave sa ground. But there is an unbalance, no, of positive and negative charge. Kaya mas daga naman ang positive. So the sphere now is not positively charged. But there is no direct contact between kadong charged nga rod and the neutral nga sphere. So na-charge lang siya because of the ground. Okay? So we proceed now to Coulomb's law. So we have seen that an electric charge exerts a force of attraction or repulsion on other electrical charges wherein the direction of the force vectors depends on the signs of the charges. So these attractive or repulsive forces are called electrostatic forces. The factors that affect the magnitude of these electrostatic forces were investigated by French physicist Charles Augustin de Coulomb and was summarized in his law, which is called Coulomb's law. So he was able to find out that electrical forces are directed along the line joining the two particles and inversely proportional to the square of the separation distance between them. So this is like, for example, charge particle 1, charge particle 2. So they are at a certain distance r. So the force is directed along the line joining the two particles. Okay? And then this r is the distance between their centers actually. So this force, the force acting on them could be directed towards each other. Kung same sila nga positive or same sila nga negative, or it could be directed away from each other. I mean, kung positive ug negative, directed towards each other, pero kung both positive, directed away from each other, or both negative, directed away from each other. And then electrical forces are meaning the magnitude. are directly proportional to the product of the magnitude of the charges of the two particles. So let's say the charge of particle 1 is Q1 and the charge of particle 2 is Q2. And electrical forces are attractive if the charges have opposite signs and repulsive if the charges have the same sign. So mathematically, we can say, so this one, this Coulomb's law is summarized in this formula, F equals K sub E, Q1, Q2 over R squared, or we can just write that as K Q1, Q2 over R squared, where K here is the Coulomb's constant, and that's equal to 8.9875 times 10 to the power of 9 Newton meter squared per Coulomb squared. So we can just call that K. And the R is the distance now between the centers of the charges. So here, if this is Q1 and Q2 and they have the same charge, then they are going to repel each other. And if they have opposite charges, then they're going to be attracted to each other. So this is an attractive force, and we have here a repulsive force.